This is podcast 2.4 for chemistry, and we're going to talk about the Bohr models and Lewis dot diagrams. So with a Bohr model, there's a couple things that you need to know. Bohr models are, if you remember, where we put the nucleus in the middle and then we have the energy levels with electrons around them. So we need to know that electrons exist in energy levels and that the energy levels are the same as the row number that the element is in. There are certain numbers of electrons that can be held in each row number, and we're only going to worry about going through row number 4. So it goes 2, 8, 18, and 32. That should make sense because the bigger your energy level gets, the more electrons it can hold. And you need to remember to fill your electrons from the inside to the outside. So we're going to start on the inside ring and work our way out. And we want to place the protons and the neutrons in the center. And you can just put however many protons and however many neutrons there are right in the middle of your structure. So we're just going to do a bunch of examples with these. The first one is nitrogen. Nitrogen, if you looked it up on the periodic table, has an atomic number of 7. And then it has a mass number that we would round to 14. And this is neutral nitrogen, so we're also going to assume then that the electrons, when we get there, will be 7. And we're going to start in the middle. So protons are the atomic number. I'm going to put the 7 protons in the middle. 14 minus 7 is 7 neutrons. Then I have to fit my 7 electrons in here. So I'm going to put 2 here. And then I go to the next energy level. And I only need 5 more. So I go 1, 2, 3, 4, and then 5. I like to pair them up because 8 is the ideal number for these. So everybody gets their own space. If there's 4, any more than 4 though, they start to pair up and look like this. So that would be it. That's all you have to do for these is just put the electrons in the correct place around the rings. The next one we want to do is magnesium. If you looked up magnesium on the periodic table, it has an atomic number of 12. So it has 12 protons. It has a mass number of 24. So it would have 24 minus 12 is 12 again, so 12 neutrons. This is neutral. So the protons and the electrons are going to be equal. So we have 12 of everything. So I have my 12 protons. I have my 12 neutrons. And then I just start adding in my electrons. I can put 2 here. And then I'm going to go 1, 2, 3, 4. And then I give everybody a buddy. 5, 6, 7, 8. So that's a total of 10 electrons. And then I go to the next energy level and I have 2. And if you can look at the periodic table, if you looked at the first row has 2 elements in it. And the first row can hold 2 electrons. The second row has 8 elements across, if you count them all up. And it can hold 8 electrons. And you can just kind of keep going like this. So if you see magnesium is the second over in the third row, so those 2, because it's the second over in the third row, are where those 2 electrons come from. Okay, now we want to do the magnesium ion. So if you looked at magnesium, you know it's in group 2A. That means it has 2 valence electrons. If it has 2 valence electrons, everybody's trying to get to 8. So it's going to be a lot easier for magnesium to lose 2 electrons rather than to gain 6. It's going to take a lot less energy to do this. So if it loses 2 electrons, if magnesium has 12 protons, 12 neutrons, then if it loses 2 of its electrons, it no longer has 12, it only has 10. So when I draw this, my nucleus is still going to look the same as the last one we did. But now my outer ring, I have my 2 electrons in that energy level, and all I need are 8, which means my second energy level is going to be completely filled, and I will no longer have any electrons in the third energy level because those were lost. They went away. This is now really stable because it has this full outer energy level. That's why it wanted to lose its 2 electrons. Okay, chlorine. Chlorine has 17 electrons. It also is going to have 17 protons because its atomic number is 17. And then to figure out the neutrons, we have to take 35 minus 17, and that's 18. So to do this one, we have our 17 protons, 18 neutrons, and then we just go crazy here, drawing in our electrons. So that's 10, and I need to get up to 17. So 11, 12, 13, 14, 15, 16, and 17. So we have the 7 here on the outer energy level, and that's what that one would look like. I'm going to leave this up and go to the next one because this one is asking about the chlorine ion. So I'm going to look back here. This is the one we just drew for neutral chlorine. Neutral chlorine, we said, had 17 electrons. Chlorine is in 7A, so it has 7 valence electrons, and you can see them. We put them all here in this third energy level. Now, it's going to be a lot easier for chlorine to pick up one more here to get 8 instead of losing the 7 that it already has. So that means chlorine's charge, if it picks up one more electron, is going to be a -1. And all we would have to do is just add that 8th electron to that energy level. So the chlorine ion just has a difference of having 8 in the third energy level. Okay, Lewis dot diagrams. Lewis dot diagrams are a little different because we only deal with the valence electrons. We need to figure out first how many valence electrons there are, and then we just put dots around the symbol. Remember the rule, and we've been talking about it. If beryllium is in 2A, it has 2 valence electrons. Carbon's in 4A, it has 4 valence electrons. And we want to put the electrons around the elements, and we want to pair them up only if there are 5 or more valence electrons. So, once again, these here would have 1 valence electron, 2 valence electrons, 3, 4, 5, 6, 7, and 8. The only exception there is this one who only has 2 electrons, but everybody else has 8. Make sure you can figure out how many electrons these elements have so you can do these correctly. Okay, so our practice problems here, we have beryllium, carbon, and sulfur. Beryllium, we said, was in group 2A, so it has 2 valence electrons. And when I'm doing these, I like to think of them as having 4 different areas around because they don't want to pair up until there is more than 4. So beryllium's Lewis dot diagram would look like this. Carbon is in 4A, which means it has 4 valence electrons. So I would get a dot here, here, down below, and there. And then sulfur is in 6A, so it has 6 valence electrons. So I would go 1, 2, 3, 4, 5, and 6. And that's how you draw the Lewis dot diagrams for these. Really quick, not too complicated. All right, the only one you need to watch out for is helium. And just like I was saying before, you would see column 8A and think everybody has 8. Well, helium only has 2. So when you draw the Lewis dot diagram for helium, it either needs to look like this, or you can match them up just like that if you'd like to. It doesn't matter, you can do it either way. Okay, that is the end of podcast 2.4. You just really need to make sure you can find the number of valence electrons and that you know the difference between a Lewis dot diagram and a Bohr model.